¿Me quieres? No me quieres. Ya, claro que te alejes. ¿Me quieres? No me quieres. Ya, claro que me dejes. Todo estaba tan bonito hasta que empezó a fallar. Hubiera sido infinito, pero este amor no vale más. Ya te digo la verdad, yo no vuelvo para atrás. Quiero ya mi libertad. Tú no vales más, no me llames más. Saco mis cadenas, basta de peleas. Aire no me queda, no me tiene penas. Saco mis cadenas. Tú llevaste todo, me quedé sin tono. Lo dejaste roto, me caí al fondo. No me quedes sola, tengo a Dios mis horas. No te necesito más. Todo estaba tan bonito hasta que empezó a fallar.
Hello and welcome to this week's episode of Inspired Earth. We've got some updates on PFAS, and then scientists create magnets with light on non-magnetic materials. That's pretty wild, as well as a paper battery. And then we'll do a rescue about a goat at the end. So we got a new update on PFAS, which is pretty interesting. And here we are with BBC PFAS limits forever chemicals in tap water for the first time. So we've flip-flopped again. On Wednesday, officials finalized a rule that would require local governments to remove 6 versions of the chemicals from water systems. So I've heard multiple things, not just 6. I've heard 12 chemicals. The government has allocated an extra $1 billion to help cover the cost, and the new rule would provide long-lasting health benefits for Americans. So this is good, and we're always going to look optimistically on Inspired Earth, but we're talking 6. It says 6 here. I thought it was 12, but there's 14,000 PFAS, and we're doing 6 or 12. I mean, that's good, but not good enough. It says drinking water contaminated with PFAS has plagued communities across the country for too long. And I have a video queued up, but I just found out that Flint, Michigan was one of these that are super highly affected, and I just feel so bad for them. You know, can we not get it together? This community has been affected for decades. I'm surprised there's even people living there at this point. And here we are stacking bottles of water up for them again, and last time we stacked bottles of water for them, and their leaders were so incompetent they did not hand out the water, and it just went to waste while everybody was needing water. So hopefully we can actually hand out the water this time whenever we all send it there to the people that need it, rather than just hoarding it inside of government buildings. The EPA says that between 6% to 10% of 66,000 public water drinking systems across the U.S. may have harmful levels of pollutants of PFAS, and that PFAS is used to repel water, oil, grease, and are used in hundreds of products from dental floss to cookware to firefighter foam. They are now called forever chemicals because they remain widespread in the environment due to their lack of degradation, despite the fact that most U.S. companies have phased out manufacturing of the most well-studied types. So yeah, that's just the ones that we're studying. There's a crazy amount that we're not. The EPA has found that almost no level of exposure to PFAS is safe. As well as cancer, the chemicals have been linked to reproductive issues, decreased immune function, thyroid disease, and asthma. Experts previously told the BBC that communities with poor drinking water systems stand to reap the most benefits from the new limit, but could also struggle to pay for the new treatment systems, which can cost millions of dollars for small towns. The Biden administration says $9 billion is now available through a bipartisan infrastructure law passed in 2021 to help communities address PFAS. So they knew all the way back then. And on that note, I'm just going to play this video.
The Biden administration has focused on clean water following the discovery of water heavily polluted with lead over the past decade, especially in poorer communities in Flint, Michigan, Jackson, Mississippi, and elsewhere. Environmental watchdogs and prosecutors say manufacturers knew the compounds were dangerous years ago.
For years, companies have dumped PFAS and other chemicals that last forever into our lakes and rivers, even when they knew that these chemicals damaged people's health and our natural resources' well-being.
The EPA is providing $9 billion for PFAS contamination from an existing $20 billion fund to rebuild drinking water infrastructure.
So that was clearly insane. And here we have 14,000 chemicals that have been made popular since the 1950s for diverse skills in resisting heat, water, grease, and stains, commonly found in frying pans, clothing, cosmetic, insecticides, food packaging, as well as specialty industry products like firefighting foam, and they are in the environment and our bodies and don't degrade further. PFAS have been linked to environmental and health issues, including cancer, but a lot remains unknown about the true scale and potential impacts of the problem, including how much is in our water supply. So there's this saying, dose makes the poison, and that you can have toxic stuff all day long, but it has to come to a certain dose to be able to like come into the area where it's actually efficient, where it causes a change in something. You can have like bits of poison, like take for example salt. You know, like you can have too much salt and it become poisonous, but it's only if you have too much of it. So they're trying to find what is like the safe amount of this stuff. And earlier they said that there is no safe amount. There is some things that there is just straight up no safe amount, like mercury and lead. And I'm thinking that this is going to be one of those. It would be really nice if we could find out that it's not as bad as it could be, but it's not sounding like it's going to be that way. And the fact that they're like hiding it and that they knew about it for so long ago, that probably means that it's not good. We already knew that PFAS is pervasive in the environment, but I was surprised to find out that the large fraction of sources of water that are above drinking water advisory recommendation, we're talking above 5%, and it goes over 50% in some cases. And the research team pulled together PFAS measurement from sources around the world, including government reports, databases, and peer-reviewed literature. Although they collected more than 45,000 data points, which spanned over 28 years, it's the first study to quantify the environmental burden of PFAS on a global scale. And that the concentrations of PFAS in Australia, with many locations above recommended water drinking levels, this tended to be in areas where firefighting foams have been used in the past, like military institutions and fire training facilities. Also think about that they just had massive wildfires in Australia. So they could be dumping that all across the most beautiful regions. And same thing in California and America and Colorado and all over the place. Canada, Brazil, anywhere that they're fighting fires, you're contaminating the area with this PFAS stuff, which they don't even need necessarily to be, like, if we were properly sustaining the forests and jungles, then we wouldn't need to spray PFAS everywhere, but that's a whole different conversation. But Professor O'Carroll stresses that these PFAS traces are found in source water, such as dams, and not drinking water itself. Drinking water goes through treatment plants, some of which are designed to reduce the amount of chemicals such as PFAS in our water before drinking it. But some water providers, for example Sydney Water, don't routinely measure the broad range of PFAS potentially in our drinking water. Drinking water is largely safe, and I don't hesitate drinking it, he says. I also don't suggest that the bottled water is better, because it doesn't mean that they've done anything differently than what comes out of the tap. But I certainly think that monitoring PFAS levels and making the data easily available is worthwhile. Most people in Australia and in many places around the world are likely to have low levels of PFAS in their bodies. However, in the United States, it's 97% of people have PFAS, even if it's low level. According to an Australian government expert health panel, there is limited to no evidence that PFAS poses clinically significant harm to human health. Although further afield, peak bodies in the US and Europe suggest that PFAS is linked to adverse health outcomes such as lower birth weight in babies, higher levels of cholesterol, reduced kidney function, thyroid disease, altered sex hormone levels, reduced vaccine response, liver and kidney and testicular cancer, and in 2023, World Health Organization declared PFOA, a type of PFAS, a Category 1 carcinogen. And that's just one type. And there's 14,000 types, they say. So Australian government expert panel can go and drink PFAS, for all I have to say about that. While PFAS has been linked to many of these health outcomes, they haven't necessarily been shown to cause them. But given the potential risk and forever nature of these chemicals, many regulatory bodies have tightened PFAS use and introduced safe drinking water limits as a precaution. Two forms of PFAS initially raised concerns about 20 years ago, PFAS and PFOA, which 14,000 other ones, and they knew from 20 years ago. But these chemicals are regulated to different extents around the world. In the US, the proposed drinking water limits for PFOS, and PFOA are 4 nanograms per liter. A third PFAS is regulated in Australia called PFHXS. Here, the sum of PFAS and PFHXS is limited to 70 nanograms per liter, well above the 4 nanograms per liter combined PFAS and PFOA limit in the US. But our acceptable limits of PFOA in drinking water is even higher. On the other hand, PFOA is regulated in Australia at 560 nanograms per liter, which is 2 orders of magnitude higher than in the US. So I guess the Australians are guinea pigs on this. If they come out all right, then maybe we'll all be all right. While Australia limits seem relaxed compared to the US, both countries recommend drinking water guidelines pale when compared to Canada's. Here, rather than limiting only 2 or 3 forms of PFAS in drinking water, Canada tallies up the sum of all 14,000. Wow, that's like almost a science-based approach. Crazy. Why is Canada always like ahead in so many different things and just common sense? It feels like this should just be common sense. And limits the overall number to 30 nanograms per liter. That's like a healthy medium, I feel like. The study found that 69% of global groundwater samples with no known contamination sources exceeded Health Canada's safe drinking water criteria, while 32% of the sample exceeded the U.S. proposed drinking water hazard index. There's debate about what level PFAS should be regulated. Australia has much higher limits than the U.S., but the question is why. Both health bodies would have different reasoning for that, and there's not really a strong consensus. An underestimated risk. The study suggested that actual PFAS pollution in global water resources could be much higher than suspected. This is in part due to only monitoring and regulating a number of the 14,000 PFAS in existence, and also because the levels of PFAS in consumer products are higher than expected. There's a real unknown of PFAS, and we're not measuring in the environment. Commercial products like garments and food packaging have a lot more PFAS in them than we realized. So the clothes we're wearing and the food we're eating has this stuff in it. It's a lot to take in, but like we really need to understand what is happening around us. And it's frustrating. It's very frustrating, especially them knowing this stuff for so long and continuing to put it on there. I mean, you look it up, this stuff is like every single baby product basically is like mandatory to have this stuff on it. It's mandatory for baby stuff to be fire retardant. So that's what this stuff is like fire retardant. So our babies are getting exposed to this mandatorily from the very beginning. We need to look at this stuff. We never did any real like health impact studies of how people in the last 100 years were affected by lead gasoline and lead paint and lead everything, like that's why we had to take lead out of gasoline, was because there was so much lead in the air and people were getting damaged by that. Not only the environment, because it was ending up in our water. This is like the exact same type of case. We never did any studies to see how many people were damaged or to what extent people were damaged from that exposure to the lead, which we already know there is no safe exposure amount to. So this, I feel like, will be very similar to that. We will probably never know the true extent of damage to the environment or people done by this sort of stuff. It will just go into a mystery of the time, and everybody will get away with this. That's at least historically what has happened, and it shouldn't be what happens, because this is raising awareness right now. So we've never had people so upset about PFAS and so many people talking about PFAS before. And this all started with lead, with them finding lead in the water with Flint, Michigan. So again, that's another analogy parallel back to lead. And it's honestly shameful. Like, whenever I see that whole Flint, Michigan thing, and again with like the children, that's who is most affected by this sort of stuff, and the poor families. And I guarantee you, if this was a rich neighborhood or community, this would not be happening the same way. But they don't have the resources to be able to advocate for themselves. And that's why it's been going on for 20 years in the same community. There's a real unknown amount of PFAS that we're not measuring in the environment, says Professor O'Carroll. Commercial products like garments and food and packaging have a lot more PFAS in them than we realize. This means we're likely underestimating the environmental burden posed by PFAS. Professor O'Carroll and his team are now trying to develop their research by quantifying these levels of PFAS from commercial products in the environment. They're also working to develop technologies that can degrade PFAS in drinking water systems and looking at developing predictive models that determine whether PFAS will go in our environment. Wow. Developing technology to degrade PFAS in our drinking water. So there we go. We have a solution right there. Like, the fact that they're even saying that this is possible. But we have to figure out how PFAS will associate with different parts of the environment and our bodies, proteins, for example, because we have no idea how bad this stuff is. These studies will be in progress over the next 2 years and aim to be completed by 2026. In the meantime, manufacturers and consumers alike need to be careful and do due diligence when using products containing PFAS, which is basically everything. We should have been judicious about the use of some of these chemicals. Just because they're available doesn't mean we should use them. Yeah, that's it's like a way of life. Here we have scientists use laser light to achieve quantum states at room temperature. A global team of researchers have revealed a quantum breakthrough that could transform current computing and data infrastructure. The team used light to induce quantum behavior at room temperature, turning non-magnetic material magnetic. On the quantum level, particles defy classic laws of physics and represent magnetic or superconducting behavior. Researchers have been studying quantum particles to be able to replicate their behavior in other materials. Magnetism is inherently quantum mechanical, and we've come to understand that, so has our ability to increasingly grown to crack open the fundamental world. Quantum technology stands to impact of the most relevant industries in our world at the speed of light, and light, it turns out, held the key to opening the door. Researchers magnetizing a non-magnetic material. The research team successfully magnetized strontium titanate, a gemstone, using laser light at a particular intensity and frequency. By doing so, the team has become the first in the world to demonstrate laser light's ability to induce magnetism in non-magnetic material at room temperature experimentally. Quantum experiments of this nature have worked only in extremely cold conditions and laboratories until now. While a physicist claimed to discover a superconductor capable of working at room temperature in March 2023, his findings were deemed to be manipulated earlier this month, which we need to talk about. That's actually super interesting. That I'm going to try to do next week. or at least like talk a little tiny bit about it, because it is relevant and it is important to talk about. The innovation in this method lies in the concept of letting light move atoms and electrons in this material in a circular motion, so to generate currents that make it as magnetic as a refrigerator magnet. And the team was able to do so by developing a new circularly polarized light that stirs up titanium atoms and generates currents. In this case, the light had a corkscrew shape, which seemed to be the trick. That's very interesting. Not only did the team magnetize a non-magnetic material, but they also demonstrate that their approach works. This approach can now be applied to other insulators, reducing the need to use metals for their magnetic properties. In the long run, this opens up for completely new applications in society. This opens up for ultra-fast magnetic switches that can be used for faster information technology transfer and considerably better data storage, and for computers that are significantly faster and more energy efficient. Light has just opened up a new chapter in technology by being able to manipulate materials at a quantum level and room temperature. This research team comprises scientists from Stockholm University in Sweden, University of Connecticut, and the SLAC National Accelerator Laboratory in the US, National Institute for Material Science in Japan, and Sapienza University of Rome, and Venice, Italy. It's a whole world working together on that one. This one was also very interesting, April 9th, and research finds Americans are supportive but misinformed about fusion energy's promise. And here we have the most frequent images that respondents provided when asking about different nuclear states. Research led by Hank Jenkins Smith, PhD, Director of the Institute of Public Policy Research and Analysis at the University of Oklahoma, explores American adults' perceptions of fusion technology. The first of its kind study reveals broad public support from respondents, but their limited knowledge of the technology and frequent misconceptions could pose a challenge to those seeking to develop fusion in the U.S. Our research questions public perceptions of nuclear fission and whether these opinions could affect the potential for fusion energy to become a major power source for the U.S. electrical grid. It turns out that these social perspectives are significant and must be addressed by engineers, physicists, and regulatory specialists for the technology to be widely supported. Fission energy, or the splitting of atoms, differs from fusion, which combines two atoms under extreme heat and pressure. According to the International Atomic Energy Agency, the fusion process is intrinsically safe. It offers an abundant source of energy with very little greenhouse gas emission or long-lived radioactive waste. The same cannot be said for fission. We discovered that less than half of all respondents had heard of fusion, and many confused fission and fusion. This confusion, along with pop cultural references of Godzilla, Homer and The Simpsons, and memories of spectacular accidents like 3 Mile Island, Chernobyl, or Fukushima, or you might as well throw in that Norfolk train disaster that we were talking about, causes them to believe that fusion technology is extraordinarily risky. Based on their research findings, Jenkins Smith's team determined that the public wants decision makers to think carefully about the safety constraints and future incentives for fusion energy in America. The fusion industry should look at how the fission industry has developed an amazing safety culture. They've built in many layers and processes to reduce the possibility of accidents. There are things that fusion regulators must develop ahead of time rather than waiting for a disaster to strike and fixing the problem later. According to Jenkins Smith, messaging is an important takeaway from this research. He believes there are potential opportunities for misleading statements, leveraged by fusion opponents to confuse and scare Americans, to undermine public trust for information from technology supporters. Because the public is not well informed, opponents could fairly easily generate false narratives linking fission to fusion and thereby poisoning public acceptance of fusion. To combat this, developers, regulators, and advocacy groups must be aware and careful about what they say about fusion. They must have humility and avoid making overly optimistic claims that will be difficult or impossible to achieve. Doing so will go a long way in retraining societal acceptance. Study respondents currently expressed high trust for regulators and operators of prospective fusion energy facilities. These positive views of fusion are based in part of technological optimism. Americans have a propensity to believe that new technologies can help improve their lives. We're technological optimists. The more technologically optimistic someone is, the more likely they are to support fusion energy. Harnessing this optimism could help grow our economy, tackle climate change, and address international security and energy concerns. Yeah, imagine if the whole world wasn't all fighting over oil and like stuff like that. We might figure out that we actually like each other instead of fighting over energy. But here we have researchers develop paper battery that generates power from water and air. Researchers at Tohoku University have developed a paper-based magnesium air battery plane that is eco-friendly and powerful. And this is from Interesting Engineering. Step aside lithium and alkaline, magnesium might be the next power player in the battery world. Studies have shown that magnesium-based energy storage devices could be safer and more powerful than its metal competitors. Magnesium, lithium, and metal air batteries. The Earth has more magnesium than lithium. Magnesium ions also have higher energy density and 2 positive charges. Lithium ions are smaller and only have a single positive charge. Most might be familiar with lithium and lithium-ion batteries. They're found in flashlights, cameras, security systems, even cell phones, tablets, vaping devices, tools, e-bikes, and the metal air battery uses oxygen to generate electricity. So it's an oxidizer. The magnesium air battery from Tohoku University is innovative, however. The researchers made it out of paper, first of all, and it runs on water. In a fascinating new study, researchers documented that the respiratory system of plants inspired them to make the magnesium air battery. So this is about photosynthesis. It's crazy how we take so many examples of biology and then apply it to our technology and manufacturing stuff, and how advanced biology is and nature is that we can't replicate that stuff. So we just look at it and copy it. You know, plants, like the stuff that we all take for granted, everything around us, we just discovered a water-based battery just by looking at how plants breathe. That nobody's ever come up with this before. And that's just from plants. I just can't get over that, you know, that how simple some of this is, and that's been in front of us for so long. We thought that if a system in which paper absorbs electrolytes by a capillary force, like plants suck up water from the ground, could be applied to magnesium air batteries, the problem of magnesium dissolving in the electrolyte and self-discharging would be solved. The battery performance depends on the water-absorbent paper. Paper-based devices reduce the use of metals and plastic. So this magnesium air battery poses the least threat to the environment. Metal air batteries, typically regardless, use heavy metals. They can't just be thrown away. Even if they contain heavy metals in small quantities, they're still dangerous for the environment. An eco-friendly battery that delivers high performance. Finally, the paper-based magnesium air battery has a high-performance output. One of the hurdles scientists have faced with using magnesium as an energy source is low mobility. Lithium ions move faster. Studies have already shown that magnesium ions can be manipulated to have a faster mobility rate. After all, no one wants to wait hours and hours and hours for their electronics to charge. This paper-based magnesium air battery thus provides itself on 2 levels. It could become the first eco-friendly energy storage device that meets high-performance standards. A material as thin as paper might just blow the heavyweight metals away. That's crazy. that's going to take some time to process, I feel like. So we'll move on to this rescue pretty quickly, in that a mountain goat, got out seemingly from a action movie plot. The goat from Kansas City Pet Project, named Jeffrey, your run-of-the-mill goat with a penchant for climbing. He had climbed up a high ledge on Monday and reached the top of a bridge about 80 feet above water in Swope Park area. However, he encountered some difficulty at the highest point. The goat had a mishap while attempting a platform jump, causing concern among the rescuers when he became entangled in some rope and fell. The fire department swiftly freed him as a veterinarian sedated him. The goat was then carried to safety before he was taken to the shelter's veterinary clinic. Tori Fugate, a spokesperson for the nonprofit, said Jeffrey is doing great despite all he's been through, and they have tons of pictures. Originally a stray, they found him and made him famous as a household pet. The shelter reported that despite the efforts to keep him safe, the animal's desire for adventure left him to jump the fence of his new home. The family reached out, claiming that Jeffrey was their missing pet. It turned out that Jeffrey's real name is Chug, and he has quite a backstory. His original family, who lovingly raised him on their farm over an hour and a half away, have been searching high and low for their beloved Chug since he disappeared in February. According to Fugate, Chug is currently on his way back to his rightful home, where he will be reunited with his family and original goat family. Aw. Let's raise a glass or bale of hay to this heartwarming reunion and wish Chug a future filled with endless adventures and boundless love. Dang, that goat got an hour and a half away and was gone for a while. That is a very funny story. He got lucky. Could have gotten eaten by a coyote or something. Definitely. And then got lucky getting saved, getting wrapped up in the rope. Why was there a bunch of rope just laying around on the bridge? Who knows, but at least the goat was saved. And kind of had a short one this week. Had a lot going on, so I'll be sure to put some more out next week. Alright, be safe out there, guys.
But I'm